I welcome you all to this morning session of platform presentation. It's a little early in the morning, so we are a bit thin on the ground. I think we'll start the judges for today are Dr. Renu Saigal and Dr. Carlos Enrique Toro Gutierrez. So I welcome you both to this. The presenters are Dr. Sukanya Mohanty, Dr. Christina Maria Selvat, and Dr. Pratik Pio. The presentation will be for a period of 6 minutes, followed by 3 minutes of questions from the judges. Then we move on to the next presentation. Please stick to your time. There will be a bell which is rung at the end of 6 minutes. So we'll start the first presentation. Without further ado, I welcome Dr. Sukanya Mohanty to the stage. She is going to talk on association of TLR2 polymorphisms, 23 base pair insertion deletion with ankylosing spondylitis, a hospital-based case control study.
Good morning everyone. I am Dr. Sukanya Mohanty, a third year postgraduate student in the Department of General Medicine, SCD. I will be presenting a topic on association of toll-like receptor 2, 23 base pair polymorphism and ankylosing spondylitis, a hospital-based case control study. So toll-like receptors are members of the family of pattern recognition receptors and are important for innate immune system. However, inappropriate activation of TLR pathways can lead to chronic inflammation. Recently, a 23 base pair insertion deletion polymorphism at 5' untranslated region of toll-like receptor gene was documented in patients with malaria and dengue by a group in Odisha. This polymorphism was associated with high TNF-alpha levels. TNF-alpha is the most important inflammatory cytokine in the pathogenesis of ankylosing spondylitis. Now coming to the aim of the study, it is to study the prevalence of TLR2 polymorphisms in patients of ankylosing spondylitis. We also try to correlate between TLR2 polymorphisms with clinical disease severity. Now coming to the materials and methods, 100 diagnosed cases of ankylosing spondylitis were recruited for this study. For the controls, we took 70 healthy volunteers. The blood samples were collected as per standardized institutional protocol. Disease severity was assessed by disease severity indices such as BASDI, ASDA-CSR and ASDA-CRP. ESR was measured by Westergren method. Serum CRP was measured by quantitative turbidimetric test. Serum TNF-alpha was measured by ELISA. Now for the detection of TLR2 polymorphism, DNA was extracted from EDTA whole blood using the given extraction kit. PCR was performed with TLR2 primers. As shown for the forward sense and the reverse sense, as can be seen in the sudden blot picture, a single band at 286 base pair was taken as wild type for insertion and insertion. A single band at 263 base pairs was taken as deletion and deletion homozygous mutation. And 2 bands each at 286 base pairs and 263 base pairs was taken as heterozygous mutation for insertion and deletion. Now coming to the results for the demographics and disease activity, as can be seen in the table, all the patients for the disease group and the control group were male. The mean age was around 31 years for the disease group, and for the control it was 28 years. The mean duration of disease was 2.07 years. Now coming to the distribution of TLR2 polymorphism in ankylosing spondylitis patient and in the healthy controls, as can be seen in the given table, the homozygous deletion genotype was significantly higher than the wild insertion homozygous variant in ankylosing spondylitis patients compared to healthy controls. The last row in the table, which was significant, with a p-value of 0.0453 and can be seen in the table. And then these are the bar graphs showing serum TNF-alpha levels in the controls. As can be seen, in the heterozygous insertion deletion mutation group, the levels of serum TNF-alpha levels are significantly higher than the homozygous insertion group. Now coming to the serum TNF-alpha levels in TLR2 genotypes of patients, we can see that in the homozygous and heterozygous deletion mutations, the TNF-alpha levels are significantly higher than the homozygous insertion group, the red bar and the green bar as compared to the blue bar. Now these are bar graphs showing comparison of disease severity indices in ankylosing spondylitis patients. As can be seen, the deletion groups, both homozygous and heterozygous, show higher disease activity in ankylosing spondylitis patients. These are the bar graphs of BAS5 and BAS8, and these are the bar graphs for ASDAS ESR and ASDAS CRP. All these graphs show that the patients with mutation for homozygous or heterozygous deletion groups have higher disease severity indices. Now coming to the conclusion of the study, the homozygous deletion genotype was significantly higher than the wild insertion variant in ankylosing spondylitis patient compared to healthy controls. The serum TNF-alpha levels were also higher for the heterozygous deletion groups in healthy controls as well as heterozygous deletion and homozygous deletion group in ankylosing spondylitis patients. Now, the clinical activity indices such as BASDAG, ASDAS ESR, ASDAS CRP are higher in both heterozygous deletion and homozygous deletion genotypes in ankylosing spondylitis patients. And the functional index BAS5 is higher in both heterozygous and homozygous deletion genotypes in ankylosing spondylitis patients. Thank you.
I request you, in which way do you think that this can be used in clinical practice?
So actually we are trying to find out mutations which enhance the disease activity in patients. So this, in a place like Odisha, where we are endemic for dengue and malaria infectious groups, so we try to find out mutation which lead to severe malaria, severe dengue, leading to high mortality. So we are trying to correlate if these mutations are going to affect the disease severity in ant spot as well. So we see that the inflammatory markers are higher. So these patients are prone to higher disease activity. So that's how we are trying to find out patients with mutations prone to higher disease activity.
So, congratulations for a good paper. One was, would you look at any disease control like psoriatic or even rheumatoid to look at this if that's happening there also? And the second question is, what he's saying I think is relevant in the sense that if you don't have with these deletions, would you prefer something like IL-17 in these patients? Did you look at IL-17 or you want to look at that as well? Because we use that in therapy.
Sorry, sir.
Because we use secukinumab in treatment, which is anti-IL-17. Would you want to look at IL-17 levels also? And the first question was disease controls.
So for the disease controls, presently we have taken only healthy controls. So this is a good idea. We can take other group arthritis groups as well. And for IL-17, we can look into that also. Presently we are concentrating on TLR2 mutations.
Are there any more questions? I think we can stop now. Thank you.
Protein level, and there are many complement genetic deficiencies that have been reported to be associated with SLE risk. Today I am going to focus only on the complement C4, which is present on the MSC class 2, which is present on the MSC complex, and this gene as such is also very complex. There are 3 levels of complexity as you can see in this image. This C4 gene exists as two isoforms which are 99.9% identical except for the 5 nucleotides that differentiate these two at exon 26. In addition to this, they also exist as either long or short forms depending on the insertion of a human endogenous retrovirus in the intron line. And besides that, they also exist as copy numbers. So an individual can have 1 copy of C4, 2 copies, 3 or 4. Maximum 8 copies have been reported so far. And based on the, and these copies can be either C4A or C4B or can be long or short forms. So we sought out to assess the C4 genetic diversity in a cohort of SLE and healthy controls that were recruited at Jawaharlal Institute of Postgraduate Medical Education, Puducherry. And we decided to characterize what are the frequency of C4A and B in this cohort and whether these A and B had HERV insertions in them. And then we also measured the serum cytokine levels and their disease activity, and then correlated their levels and disease activity with the genetic part of it. So the characterization of copy numbers were done by a droplet digital PCR, which is nothing but like a normal PCR, but you mix all the components that are required to amplify a target gene as well as a reference gene with oil to create water and oil emulsions. So your target is randomly distributed into droplets. Then you amplify these droplets separately as an individual PCR reaction. So there are 20,000 droplets that are being generated and amplified, and you then read the signal like in a flow cytometry like machine, and based on the amplification for your target gene as well as your reference gene, you will get the signals. And then you decide them as a positive signal or a negative signal. So this is the clinical characteristics of our patients. And as you can see, most of them had musculoskeletal and cutaneous manifestations. 46% of them had lupus nephritis and 33 had neuropsychiatric SLE, and most of our patients had low complement levels and they all had a very high disease activity. So coming to the distribution of the C4A and B genes in these groups, we found that 2 copies of both C4A and B were more frequent when you combine controls and cases. But when you want to see the difference between the controls and cases, we found that 2 copies of C4A was higher in SLE compared to controls, suggesting that if an individual carries 2 copies of A, they may have a risk to develop SLE. And then we saw what were the copies of C4L. We also found that 2 copies of insertions of HERV predisposes an individual to develop SLE. And then we went to see what were the frequency of this human endogenous retroviral insertions in C4A as well as in C4B. And we found that insertion in C4A gene predisposes an individual to SLE, especially if they have 2 copies of HERV insertions in their C4A gene, whereas insertion in the C4B gene did not pose any risk. Similarly, the short forms, the forms without insertions, didn't have any risk as well. And then I tried to see what were the cumulative insertions that are present in SLE and control. So we found that as you can see in this graph, C4A insertions were similar in both cases and controls. But when you see for C4B, the orange and green graphs, we found that the frequency of insertions was slightly lesser in C4B compared to controls. And I went on to find out the correlation of the C4 genetic diversity with the complement levels, and I did not find any association between either C3 or C4 levels with the C4 genetic diversity, and neither did I find any association with the disease activity when analyzed for C4A frequencies and C4B frequencies. And then I went on to see if this insertion of HERV has any role in augmenting the disease activity. Although statistically not significant, I found a trend that as the copies of HERV insertion increases in C4B, there might be an increase in disease activity which needs further validation. And then I decided to see what is the gene dosage of this C4A and its insertion, C4A and B and its insertions in SLE and controls. And the first genotype, although was very frequent in the SLE group, meaning 2 copies of A, 2 copies of B with higher insertions of long forms, higher insertions of HERV can predispose an individual to SLE. But this is not statistically significant, but if there is more than 2 copies of A, then that could turn out to be a protective genotype. So to conclude, I would say that in this cohort of SLE and controls, 2 copies of both C4A and B were very frequent. And as we know, C4 null alleles, there are reports of C4 null alleles in SLE, but I didn't find any C4 null alleles. Although there were some patients who were C4A0, but I had few patients who had C4B copies. And 2 copies of C4A and its long forms are associated as SLE risk genes in this cohort, whereas C4B is not associated. And I did not find any association between C4 genetic diversity with the serum complement levels as well as disease activity, although there was a trend of association of C4BL with higher disease activity. And it's important to note that this is a genetic study that was done in a very small cohort, and this needs replication in a larger cohort. Thank you.
Thank you, Dr. Christina.
Lupus nephritis patients, neuropsychiatric SLE patients. So, clinically they are as heterogeneous as an SLE would be.
Dr. Sakar.
One comment and one question. There was this, I think 2 months back only this paper in Arthritis Rheumatoid where they looked at, I think they looked at C1q and whether 2 alleles of C4A or no allele of the that cause. And I think it's C4A. If you had 2 copies, then you were more, and they looked at the odds ratio of, as Renu Madam is saying, probably the probability of getting lupus. So they were maybe children who had just come with very non-specific kind of pains. I don't remember the exact inception this thing. And then they showed that, so I think the retrovirus insertion that you are saying may not be relevant because that they hadn't looked at that, and even then those copy numbers caused lupus. My question was, how did you come to the retrovirus thing? Could there be other viruses also which would be leading to insertions and causing this kind of a problem?
There could be, sir, but since we are dealing with C4 gene, there are many classes of HERV insertions in the human genome which are very old. This HERV, particularly HERV-K, which belongs to the K group, is especially found in the HLA region.
So that's
there are other technically very challenging study to characterize the insertions because they were quite long. So here the insertion is approximately 6.5 kbs.
I had a question. Did you notice C4 genome variation in specific antibody profiles?
Yeah, a few months back a paper came from Sweden and they have found C4A copy numbers to be associated with SSA and SSB antibodies. And if an individual is double positive, then their risk increases proportionately. If they are single positive, then their risk is slightly lower. So this has been published and we are planning to do it in the future.
Yeah.
For this presentation, I have not done the analysis.
That was the one I was referring to. Yeah, you're right.
They have reported that A and B is not a risk factor for SLE, but they could modulate the antibody profiles.
Thank you, Dr. Christina. I think we will move on to the next presentation. Phosphamide responses in ANCA vasculitis.
Good morning, everyone. So my study is titled Pharmacogenomic Evaluation of Rituximab and Cyclophosphamide Response in Anti-Neutrophil Antibody Associated Vasculitis. I have no conflicts of interest to be declared. So in ANCA vasculitis, the timeline has evolved drastically. Earlier there were studies, randomized controlled trials just to evaluate what kind of treatment we should give. The second phase is what kind of new treatment we should give. Now we want to move out of this. We want to go towards a tailored and a precision medicine approach. So how can we do this? So pharmacogenomic is an approach to do that. What is pharmacogenomic? So pharmacogenomic is a study in which we study the DNA and then we correlate the treatment response, how the drugs are responding, and whether we find any correlations, then we can choose that appropriate treatment. So this approach determines effective treatment, it minimizes side effects, it has a right dose determination approach, and it also decreases cost. So we always talk about basic research, but the basic research should also translate to evaluate a genetic study to be at a translational level. We want to have a simple test like PCR, and even a simpler version of that PCR is to evaluate for SNPs. SNPs are single nucleotide polymorphisms which occur naturally in our DNA, either in the exons or in the introns, and only a single nucleotide gets polymorphed in the form that whether it can have a wild variant, a mutant, or a variant, which is called in a genotypically term, or a heterozygote, a combination of a wild and a variant type. So, as a methodology, what we did in this study, we selected a random group of ANCA vasculitis patients from the real world settings, and the patients were predetermined by the physicians either to receive cyclophosphamide or rituximab. And at the time of enrollment of the study, we kept a DNA sample of the patients and stored it at -80 degrees Celsius. After that, we let the disease take its natural course, and then we evaluated when the patient received remission, that is the BVAS was 0, the time to achieve remission, the status of complete remission, that is a BVAS of 0 with no dose of steroids, time to complete remission, whether they developed cytopenias, whether they developed hypogammaglobulinemia due to rituximab, and whether they had relapses. So, after completing this data, then we assessed the DNA profiling, so that we were blinded of the treatment response, and then we correlated the DNA mutations. We targeted Fc gamma receptor. So what Fc gamma receptor is? Fc gamma receptor is the receptor where rituximab binds, and it can be in variant forms. The Fc gamma receptor 2A, 2B, and 3A are the more common ones. And the CYP enzyme are the metabolizers for cyclophosphamide, which convert the cyclophosphamide inactive version to active form, that is acrolein and aldophosphamide. So what the results we got for this study? As a part of initial evaluation, we had screened almost 300 patients, and after assessing their treatment response, the ones who could be easily follow, as the study was done during the COVID time, we screened 97 patients and then analyzed the treatment response of those patients. Among those 97 patients, 57 patients had received infusion with cyclophosphamide as their first induction. One patient had received both cyclophosphamide and rituximab, and 48 patients had received rituximab as their first induction treatment. And later on, a particular group of these patients had also relapses, in which some of them received induction through the same drug and some received induction with an exchange of the primary regimen. So in the results, we enrolled 97 patients. They were a variety of all type of, as like ANCA vasculitis is, a variety of all combination of patients, of which I am presenting here just the data of patients who had received induction treatment with rituximab. So of those rituximab, number of patients who received rituximab, they were 41, and number of patients in which rituximab was received as induction at time of relapse was 29. Total number of rituximab induction included in this study was 70. Number of patients who achieved remission at the 6 months of rituximab was 63. So this is the basic pharmacogenomic data of the patient at the mutant level of the single nucleotide polymorphism of Fc gamma receptor and CYP. So as of today, we did not have any of this data to begin with in ANCA vasculitis patients, that too in Indian setting. So this data is novel. For those 75 patients we analyzed, the Fc gamma receptor which we were interested in, the Fc gamma receptor 2A, had a very nice representation of variant and heterozygous population, which is followed by the Hardy-Weinberg law. The mutant should occur in an adequate frequency just to ascertain their response or not. However, for Fc gamma receptor 3A, we did not find any heterozygous variant, so we could not analyze its data further. For other variants, we had only minimal number of mutants in our population. So to study the response of remission, the Fc gamma receptor 2A variant version had an earlier time to remission with a p-value of 0.001, and the time to complete remission in the variant version of Fc gamma receptor 2A was also very early, as we can see in this figure, with a p-value of less than 0.001. I'll skip this due to paucity. So, where does this data lie in our context? In Indian scenario, earlier patients who were tried for pharmacogenomic profile were either patients from RAVE study or patients from European cohorts, in which the patients were in research settings. This is a real world scenario. So in our population of Indian ANCA associated vasculitis patient, the Fc gamma receptor, which is replicated with a high polymorphism, has a very good treatment response if we consider the time to achieve remission and time to achieve complete remission. As we can see in the US population and in the European studies, the Fc gamma receptor was just an indicator that it might be a biomarker prior to this tailored approach, but our cohort did validate this approach. So the strength of this study is that it is one of the first pharmacogenomic profile study in Indian patients, and in this the data is collected from real world settings rather than the trial settings. We have evaluated IV cyclophosphamide, which is the standard of care, rather than oral cyclophosphamide, and very good response as a validation of Fc gamma receptor SNP, which is an easy test to do, just like a COVID RT-PCR test we found out. And also, like we do, rituximab biosimilar was evaluated. We have some limitations of this study, just because we could not have a uniform approach of treatment, but like all rheumatic conditions, we can never have a uniform approach of treatment. Thank you. I would like the IRA to partially fund this study and help me present this data here. Thank you. Were GPA patients only. Of the 97 patients enrolled, ma'am, 74 patients were GPA. There were 15 MP and the rest were eGPA patients. However, for the evaluation purpose, ma'am, we clubbed them as together because the treatment which we were giving was same for all the three profile of patients. We tried to do a individual disease-based analysis, but the mutations which we got, they were very frequent, very less in frequency for eGPA and MPA. So to ascertain whether our data is true or not is not actually correct, and the initial step to do that is not right. So we cannot do the correlation individually, ma'am. The mutation should occur in a larger frequency to ascertain about those diseases. They being very rare diseases, to club them as a right approach.
Any more questions from the audience? Thank you, Dr. Pradeep.
Thank you very much.
Patients and for keeping to the time. And thank the judges also, Dr. Carlos and Dr. Renu. And we will end the session. Thank you very much for your time.